What was the first question in the pre-lab? I think we actually talked about this in essay. It asked what types of bonding potassium perchlorate has. What types of bonding did it have? Ionic and covalent. I just went over that with you just in case it wasn't clear what they were really asking. Ionic because it's potassium to nonmetals, and within the cluster of nonmetals, within the perchlorate, it's covalent bonds. On the bottom of the first page of the pre-lab, it talks about sulfate and charges and all of that. How many are planning to forget the question about are all the sulfur to oxygen bonds equal or equivalent? I can't remember how they worded it. You notice the very last sentence on the bottom of that first pre-lab page? Ask are all the sulfur to oxygen bonds the same? Here's someplace. Does it say that? I'm too far away. Is there
It
say
says,
that?
based on structure, would you predict that all the S to O bonds are identical?
So everybody's going to remember to answer that? And probably think about it before answering it? In other words, did maybe a quarter of Friday's class forget to answer that question? And we'll do all the post-lab questions. Some of them are complicated enough that I suspect people are going to be asking me about some of the post-lab questions. With the main data sheets, none of it's actual experimental measurements, so you can do pencil on everything. No matter everything today can be done in pencil. Each data sheet is sort of cut into quarter pages, gives you a formula. Then it asks you to figure out AE and NE. Did you figure out what AE and NE were? In the introduction, they teach you a particular way to do Lewis dot structures, where you have to calculate the available valence electrons and needed electrons. And that's going to be related to, is it hypervalent at double or triple bonds? That's the relationship between the two numbers. But if you like the way I taught how to do Lewis dot structures in class, you can use that method to do Lewis dot structures. You don't have to learn their method, which means AE and NE we're going to ignore. If you love their method of doing Lewis dot structures, you can fill that out. But most people won't be using that part of it unless you've already done it. In class today, weren't we doing valence bond sketches? All those hybrid orbital drawings were valence bond sketches. Weren't those fun? Wouldn't they be really fun if you had dozens and dozens of atoms to deal with? We're not going to do them. If you looked at the introduction, weren't some of the really complicated drawings valence bond sketches? So the valence bond sketch, we're going to sketch. Well, of course, do the Lewis dot structure. That's just a simple Lewis dot structure. Vesper sketch. Did everybody notice table 1 in the introduction? And it includes drawings of all the different possible shapes, all the Vesper shapes. If you're not sure how to draw a particular shape, you can refer to table 1. You'll probably end up close to copying it out of there. But I would ask that instead of using A and B like they use in the table, write down the actual atoms. For instance, when you do NO3 nitrate, right, a nitrogen in the middle and oxygens around it, not just A and B. Geometry description. I'm probably going to warn you about mistakes that Friday made. Hopefully, right? What I want you to do is write down 2 things for geometry description. The name, that's going to be what's important also for lecture, but also the ABN designation. That's more for your own practice. To learn the shapes, the Vesper stuff, the AB designations are very helpful. but the names are what people use in the real world when they discuss chemistry, like trigonoplanar, that sort of thing. Bonding description, did you start understanding that after today's lecture? That's looking at your Lewis dot structure, how many total sigma bonds, how many total pi bonds, and those should add up to all the lines that you have in your drawing. Like a nitrate, you'll have 4 lines drawn, 4 bonds. So the sum of your sigma plus pi should add up to 4. Does that make sense? I think that's all I need to talk about for the moment. Oh, I guess there's a couple more things. First off, as you build these, you're expected to make models of all of them. And then, of course, you're required to play with them. Better than that. Do a better job of that, okay? It'll help you picture the 3-dimensional shape if you build model sets. So we've got some model sets here, there are a few more on the tabletop. If we run out, we've got the hood on the right of the wall there. There's a cabinet just to the left of that hood that's full of a bunch more of these model sets, if you need them. These model sets only work for things that follow the octet rule. So there are some of these that are hypervalent, more than an octet. You can't use this model set for that. The back wall, those light tan plastic boxes, those can do hypervalent molecules if you want to use those. The other thing is, everybody needs to hand in their own paper at the end of the day. But you can work in groups of somewhere between 1 and 7, 14, no more than 19. There are 18 people.